Another way that rational expressions are like fractions is that we can multiply and divide them. So here's a little recall from when we did this with fractions. We would have a number like, say, 2/3, and we'd multiply it by 1/7, and we learned that you would multiply the numerators together and then multiply the denominators together. There was some things that you could do in here with some of them. For instance, if you had 2/3 times 7/4, you could straight up multiply them, so 14/12, and then we had to reduce them, and we would get something like 7/6. Alternately, we could reduce them before we multiplied them, and that would be divide this one by 2, divide this one by 2, because we're looking for those common factors, and then just multiply 1 times 7 and 3 times 2 to get our solution, because we can cancel out those common factors. So the exact same thing applies with multiplying and dividing rational expressions, except now we have algebra involved. So if I were to take these two pieces of algebra and multiply them together, and I can use a dot instead of an X just so that I don't get them mixed up. I could use brackets instead and have giant brackets around both of these. What I want to do is multiply the numerators and multiply the denominators, but if we blindly multiply, then we have to simplify it at the end. Instead, it's much easier to use this idea of canceling out any common factors first, because the multiplication would become a lot easier. So in this case, there's a 3x plus 2 on the numerator and on the denominator, and so the multiplication becomes a lot easier if you do that cancellation, and you'll get 2x plus 1 over 4x plus 1, and there's no common factors. Remember, you have to look for things that are multiplied for it to be a factor. There's no common factors on the numerator and on the denominator. And so we're done. Now, if you were asking what are the restrictions on this entire question, the restrictions when any part of the denominator is equal to 0. So on the first denominator, that could be equal to 0 when, and so make it equal to 0 and then solve it. So one thing that x is not allowed to be is -2/3, because if it's -2/3, that first fraction will be division by 0 and will be undefined. And then the second fraction also has a restriction. You're not allowed to have x be equal to -1/4, so the restrictions are listed out as -2/3 and -1/4, and we say x cannot be both of those. If you only look at this one, you'll only see the second restriction, so you have to look at your original question. In fact, you have to look at all steps of your original question to find out your restrictions. Let's take a look at another one. So this is a little bit from last day before we move on, but if I've got a numerator of x squared minus 25 and a denominator of x squared minus 6x plus 5, we saw last day that you had to factor, so you get x plus 5 and x minus 5, and on the denominator you get x. And now I need them to multiply to 5 and add to -6, so it's minus 5 and minus 1, and these can cancel, leaving me with x plus 5 over x minus 1. And again, state these restrictions and state it from this step. So x is not allowed to be 5 because this part would be 0, and it's not allowed to be 1, or the second part would be equal to 0. Okay, let's move back. That was just a little review. Let's move back to actually doing some multiplication. X squared minus 3x over x squared minus 3x minus 4 is our first term. We'll multiply it by x squared minus 5x plus 4 over x squared minus 2x minus 3, and we'll multiply that by x plus 1 over x minus 1. So we're allowed to cancel any common factor on any numerator with any denominator. So we can go ahead and do that after we factor. So you may have noticed that there is a lot of factoring in this unit. And there is, and we need to be fairly quick at it. So the numerator factors with a common factor of x to x times x minus 3, and the denominator factors numbers that multiply to negative 4 and add to negative 3. And then the next one is x and x, two numbers that multiply to 4 that add to negative 5 or negative 4 and negative 1. And on the denominator, two numbers that multiply to negative 3 and add to negative 2 are negative 3 and positive 1. And then I have this x plus 1 and x minus 1 on the end. If you need more time with that factoring, you can grab a whiteboard and you can factor. But we need to get the speed of factoring up. If you need some extra help with that, please let me know and I can find some extra worksheets. We can put them in the YouTube comments if some people find some, and make sure that you're really getting quick and proficient with that factoring. Back to this question, I now cancel out any common factors on numerators and denominators. So there's some x plus 1s. It really doesn't matter where I find them. I just need to find them. There's some x minus 3s. There's some x minus 4s. And that looks like it. That would leave me with x times x minus 1 on the top and x plus 1 times x plus 1 again on the bottom. And generally we write that as x plus 1 all squared. So there is my solution to this. If I were to state my restrictions, which I should do, I should take my restrictions from, generally you go from the most complicated forms. So in here, and x cannot be 4, cannot be negative 1, cannot be 3, cannot be negative 1, and cannot be negative 1. So I'm not going to list them out multiple times. I just have those 3 restrictions of 4, negative 1, and 3. Let's take a look at division. So with division, I took a reciprocal, I multiplied by a reciprocal, and then I did my multiplication steps. So we did a reciprocal, and then we go to multiplication. So this can divide by 3 and divide by 3, and you get 7/8. So a similar thing happens with algebra. If you have x squared minus 3x over x squared minus x minus 6 getting divided by x minus x squared over x squared plus x minus 2, I need to factor. I like doing that first, so I have x times x minus 3, and on the denominator, set up my brackets. Two numbers that multiply to negative 6 that add to negative 1 are negative 3 and positive 2. I keep my division sign here. To factor this one, I would think about this as negative x squared plus x, and then take out a negative sign, so you get the x term first. Then there's a common factor of x, so you really have a negative x because you take out this x, and left over would be x minus 1. And then on the denominator, two numbers that multiply to negative 2 that add to plus 1 are plus 2 and minus 1. So before I go and cancel things, I still need to take that reciprocal. And so I take my first fraction and then I change this to multiplication, and I take my numerator and make it my denominator, denominator make it my numerator. Some of you might say that's flipping this fraction over, and you get something that looks like this. Now I can go and cancel. So there was an x minus 1 in both of these terms, there's an x plus 2 in both of these terms, there's an x minus 3 here and here, there's even an x to cancel each other out, and that leaves me with a whole ton of 1s, and this actually simplifies to 1 over negative 1, which is just negative 1. That's pretty incredible. Let's not forget putting down any restrictions. I have to look at all steps, because any step where I have the possibility of division by 0 is a problem. So this step here, this step here, this step here, and this step here. Anytime that there is a possibility that the denominator is equal to 0, I could have a problem. So -2, +3, -2, it's already on my list, +1, -2, and +3, that's because these are the same, and then 0 and 1, and 1's already on my list. So I get 4 restrictions for this, which seems really weird when the answer is just -1 to have a whole ton of restrictions, but they are there. And if you take some courses in graphing these things in pre-calculus 12 or in calculus, then you might get to see how these things can simplify to something really easy, but still have a whole ton of restrictions in them. Okay, we'll get some practice in class. See you then.